From my graphing calculator, this is the graph that I've gotten. We will still need to work out the y-intercept, and hopefully we can also work out the coordinates of the endpoints. So for the y-intercept, that is when x is equal to 0. So when x is equal to 0 and x is t squared minus t, that will also be when t squared minus t is equal to 0. So if I were to factorize out t, we have this, which is equal to 0. This tells me that when x is equal to 0, t must be either 0 or t must be equal to 1. So when t is equal to 0, when t is equal to 0, let's try to find what is the corresponding y coordinate. Y will be equal to 1 over 0 squared plus 1, and this is equal to 1. So one of the y-intercept is going to be at 0, 1. And for the other y-intercept that I can see on my graph, it is when t is equal to 1. And y will be equal to 1 over 1 squared plus 1, which is equal to 1 over 2. So the other y-intercept is going to be at 0 and 1 over 2. And looking at these two coordinates, we know that this should be 0 and 1 over 2. The other one is going to be at 0 and 1. So let me indicate it on my graph. Here it's going to be 0 and 1 over 2. And here is going to be 0 and 1. As for the two endpoints, I'm going to make use of the two extreme values for t in the domain. So one of them is going to be when t is equal to minus 2. So when t is equal to minus 2, let's see what is x. X is going to be equal to minus 2 squared minus minus 2. So x is going to be equal to, in this case here, this is going to be equal to, it is going to be equal to 6. And when t is equal to minus 2, y is going to be equal to, y will be 1 over minus 2 squared plus 1. So y is going to be equal to 1 over 5. The other one will be when t is equal to 2. So when t is equal to 2, x is going to be equal to 2 squared minus 2. So it's 4 minus 2, so the x coordinate is 2. And for the y coordinate, it's going to be 1 over 2 squared plus 1, which is still the same, 1 over 5. So we have two coordinates for the endpoints. One is going to be 6 and 1 over 5. The other one is going to be 2 and 1 over 5. So looking at these two points here, this should be 2 and 1 over 5. And this point here should be 6 and 1 over 5. And this is obtained when t is equal to minus 2. And t can be equal to minus 2 as part of the domain. So this point here should be a solid dot. As for this, when t is equal to 2 in the domain, t will not be including 2, which means that for this point, 2 and 1/5, this point here is going to be a hollow dot. And next, we are going to try to work out the equation of the tangent that is parallel to the y-axis. And to do that, we are going to make use of the fact that the gradient, when the tangent is parallel to the y-axis, is undefined. So dy dx is undefined, is going to be our hint. Let's first find the expression for dy dx. So to find dy dx, we will first need dx dt. So differentiating this with respect to t, it is going to be 2t minus 1. And we will also need dy dt. dy dt, differentiating this with respect to t, it is going to be equal to minus t squared plus 1 to the power of minus 2 multiplied by 2t. So we have gotten ourselves a minus 2t over t squared plus 1 squared. So with this, we should be able to find the expression for dy dx. And for dy dx, let me write it down. For dy dx, dy dx is going to be dy dt divided by dx dt. So this is going to be minus 2t over t squared plus 1 squared divided by this. So it will be the same as multiplying it by 1 over 2t minus 1. So the expression for dy dx will be minus 2t over t squared plus 1 squared and 2t minus 1. And when tangent is parallel to the y-axis. So when tangent is parallel to the y-axis, that will be when the gradient is undefined. So it is when dy dx is undefined. So for dy dx to be undefined, we are going to let the denominator be equal to 0. So we are going to be letting this square, then 2t minus 1 to be equal to 0. So when we let the denominator be equal to 0, we have this expression multiplied by this expression. But this expression here is always positive. So if this expression here is always positive, that will leave us with just this 2t minus 1 to be equal to 0. So this tells me that t must be equal to 1 over 2. That is when 2t minus 1 is equal to 0. So when t is equal to 1 over 2, we're going to find the corresponding values for x. Because this line, this tangent, is going to be vertical. So the equation will be x is equal to a constant. And a constant can be found when t is equal to half. Substituting it back into the x expression, it will be half square minus half. So this gives us a minus 1/4, which means that the equation of the tangent is going to be equal to x is equal to minus 1/4. The first thing that we should try to do is to identify the region that the question is talking about. It is the region that is bounded by the curve C and the tangent that we found in part 2. And for this tangent, x is equal to minus 1/4. It is going to be parallel to the y-axis. So it is a vertical line that is on the negative x-axis side. So if it is supposed to be tangent to the graph and parallel to the y-axis, I believe that the tangent should be somewhere here. So let me sketch it out for you guys. So it is supposed to be a vertical line that is here. And this vertical line is x is equal to minus 1/4. And the region is the region that is bounded by the curve. The vertical line x is equal to minus 1/4 and the axis. So we are looking at this region here. And we are supposed to find the area of this region. Let me make use of integration to quote an integral that represents this area. It is going to be integrating from minus 1/4 all the way until 0 of y dx. And I'm going to replace x and y by the parameter t. So when x is equal to minus 1/4, we have found that t is equal to half. And when x is equal to 0, we are talking about this point here instead of this. Okay, because there are 2 points when x is equal to 0. I'm talking about this point, and at this point here, t is equal to 1. We have found that in part 1 of the question. So I'm going to replace 0 by 1. Y, we will replace it by t, which is 1 over t squared plus 1. And as for dx, we have worked out the value for the expression for dx dt previously. Dx dt is 2t minus 1, which means that dx, I'm going to replace it by 2t minus 1 dt. So that's what I'm going to write here, 2t minus 1 dt. So if I were to just change this into one single expression, we have a half to 1 of 2t minus 1 divided by t squared plus 1 dt. So comparing this to what I'm supposed to show, we can see that ft, the function that the question wants us to determine, is this 2t minus 1 over t squared plus 1. And a, which is the lower limit here, a is equal to half. And b, which is the upper limit, this is equal to 1. Okay, so now that we have this, we are ready to do our integration. And we got to integrate this manually because the question asks us to give our answers in exact form. So, and it's not very difficult to integrate this. I will just need to break up the integral into 2 parts. Let me show you what I mean. So it will be this divided by t squared plus 1. And this can be integrated by using ft f prime t, because this is ft and this is f prime t. Then minus 1 over t squared plus 1, which I can also write it as 1 squared, so I can make use of the formula sheet's integral to try to integrate this. Okay, it matches exactly to what we have in our formula sheet. So integrating this will get us a ln modulus of t squared plus 1. And since the expression here is always positive, so instead of modulus, you can always replace this modulus by a curved bracket. Or if you want to leave it as modulus, it is also fine. As for this, using the formula that is in our formula sheet, this is going to be tangent inverse of t. So it is going to be this from half all the way until 1. So let us substitute in the numbers. So this is going to be substituting this in. We will have a ln 2 minus tangent inverse 1 is pi over 4. So this minus pi over 4. Then minus, if I were to substitute half in, it is going to be ln of 5 over 4 minus tangent inverse of half. Combining ln 2 minus ln 5 over 4 together, we will have a ln of 8 over 5. Then we have this minus pi over 4, which is by itself. Minus minus becomes plus. So my answer is going to be this in exact form.